This will be a super important module. Well, obviously all modules are important, but this module will be about asynchronous code. And that's a really important concept in programming in general, but of course therefore also in JavaScript. Thus far, almost all the code we worked with was so-called synchronous code, and I'll come back to what that exactly is in this module. We also sometimes already worked with asynchronous code without really recognizing it, and in this module we'll take a closer look at that. In detail, we'll find what exactly asynchronous or async code is and how it differs from synchronous code and what that would be. And we'll have a look at how we can deal with asynchronous code with the help of callbacks, something we learned about already and something we already did use, with the help of promises, something we have not learned about yet, which we'll dive into in this module, and how we can utilize another syntax using two special keywords, async and await, which we also haven't worked with yet. So plenty of new knowledge, let's dive right in. Let's start by understanding synchronous code and how JavaScript works. You might remember that at the very beginning of the course I mentioned that JavaScript is single-threaded. Until now, that didn't really matter to us that much. But what single threading in the end means is that JavaScript can only execute one task at a time. So let's say we have a bunch of code where we log something to the console, call a function, then maybe in that function or somewhere else after this function ran, we disable some button, and then we maybe run another function. The important thing to realize here is that all these steps run in sequence after each other. They're not running simultaneously next to each other. Instead, JavaScript will log something to the console, then call the function and do whatever needs to be done inside of that function, then go ahead and disable that button and then call that other function. So these things happen after each other, not at the same time. We could give them a label or some ID, let's simply use A, B, C, and D, and then we could say that, for example, this second block, the B block here, runs after A, but it blocks C from running until it's finished. So the code in C won't be executed until some function executed. And we saw it in our course projects already. Take this code here, which is actually the starting code of this module. You'll find it attached to this lecture here. Here, we don't have that much code, but since JavaScript parses and executes our code from top to bottom, what happens here is that first of all, this code runs and JavaScript selects this button and stores it in a constant. Then, only once this first line finished, this second line is executed and this task is performed. And then this function declaration, as you learned, works a bit differently. That happens right at the start when JavaScript reads the file at the beginning. But then in the execution process, so to say, this line executes after these two lines executed. So that's also important for us here because we need the button to be available in order to add an event listener. So we rely on this order, which is enforced by JavaScript. If it would be multi-threaded, it could maybe execute all tasks at the same time, and here this would actually be bad because then we could not rely on the button to be available when we need it. Because if this line is executed at the same time as this line, well then the button might not have been selected yet, and therefore adding an event listener to it would maybe fail. It's not something we have to worry about though, because as I just explained, JavaScript is single-threaded and therefore this order is guaranteed. But the concept I explained in the last lecture can have a downside. What if we have certain operations that take a bit longer and that expectedly take a bit longer? Let's say we have this code here. We have a console log statement, but then we set a timeout and then we execute more code. Now the problem is set timeout might take 2 seconds, 5 seconds, 10 seconds, or maybe just 100 milliseconds. But even 100 milliseconds would be a duration we probably would not want to wait, because this operation could in general take longer and therefore block our code execution, so it prevents more code from being executed until set timeout is done, at least if JavaScript would treat this in the same way as it would treat all other code blocks. Now we of course don't just have timers. Other examples could be HTTP requests you're sending, where you're maybe waiting for a response, something we'll have a look at in the next course module. Or you might be getting the user location. I scratched this when I introduced you to the navigator object earlier in the course. We simply have certain operations which can't be finished immediately. It's not just timers, where we as a developer decide how long it should take. It's also other operations like HTTP requests or getting the user location, which simply take a bit longer. And typically, you don't want to block your entire script until these operations finish. Because blocking your script would not just mean that the next line doesn't execute immediately, it would also mean that no other code can execute. So for example, if you have an event listener to listen for a button click, then this handler function that should trigger when the button is clicked would also be blocked until the timer expired or until your HTTP request is done. So you would be blocking your entire page with these longer taking operations. And that's, of course, typically not what you want. This operation shouldn't need to wait for the previous one for this longer taking one to finish. And thankfully, JavaScript and browsers have a solution for that. We have asynchronous code execution. So if we take this example with the timer, but really just to emphasize this, the same would be true if we would be working with HTTP requests here, for example. So if we have certain operations which typically take longer, then we can actually offload them to the browser. So what we do there is we hand this operation off to the browser. By calling set timeout, we just tell the browser to set a timer, but we then let the browser do that. And therefore, our code can execute right away because now the browser is actually able to use multiple threads, one for JavaScript and one for another task, for example. And therefore, this timer can be managed in the browser detached from our running JavaScript code, so that our JavaScript code is not blocked and the browser is responsible for managing the timer. And the same for HTTP requests, where we wait for a response, or for getting a user location, where we wait for the location. The browser takes care of these tasks, manages them in multiple threads, and therefore our JavaScript code is not blocked. Now the browser, however, needs a way for it to communicate back to our JavaScript code. And for that we typically, or we often use callback functions. The idea here is that, for example, on set timeout, we pass a callback function as a first argument, if you remember, and that callback function is the function the browser should call once the operation is done, so that the browser can kind of step back into our script and execute something there once it's done, so that we can have our script continue to run, but then we're also able to do something once this longer taking operation is done. If you want to have a look at that, in this example here, I have an event listener, and this is basically a similar thing. If we would have an ongoing listener, this would block the entire script execution, because we would have to wait for, does the user now click? Does the user now click? That's not what we want to do. Instead, when we add an event listener here, we also hand this task off to the browser, which manages these listeners behind the scenes, so that our script execution can continue. But then we have this track user handler function here, which we pass as a second argument, which effectively is this callback function, the function the browser should call once it's done. So in this case, not once it's done, but once such a click occurs. So that the browser can always step back into our script execution and execute this function once a click occurs. So in this case here, we could simply console log clicked here. And as you learned already in this course, this will now only execute once a click happens. But what actually happens behind the scenes, and that's what's new, is that when we call this line, we tell the browser to set up such an event listener, and in JavaScript, we're done with it. We're just telling the browser which function to execute once this click occurs, and that is it. So now with that, if we reload this and click this button, we see clicked here. That's of course not unexpected. But the magic happens behind the scenes where the browser manages this here. And that's how JavaScript works. Everything you execute in code right away runs right away, and it blocks other script execution until it's done. It's the browser which can help you with tasks that take longer and should not block your main thread. So we have a basic idea of what the browser is doing with longer taking operations. Now let's see something interesting. Let's add a for loop here, a normal for loop where we start with I set equal to 0, but now we have a very high number as an exit condition. Let's say 10 million, and we increment I by 1 here every time this runs. Now let's also add a result here, starts at 0, and add I to result here. And this is really just a demo. So result is set equal to result plus I. We could use the shorthand for this as well, of course. And thereafter we console log result. And actually let's add one extra 0 here to ramp this up to 100 million. And now save that and reload. And you see, this takes a time until it prints the result. And you learned in the numbers section that it will have problems with such big numbers. Keep in mind that I gets bigger and bigger, and we add the bigger and bigger I to the already bigger and bigger number here. Now, the interesting thing is here that after reloading, it took a time to print this. Now, let's try to click this button before this result is there. What you'll see is that clicked only appears after the result is there as well. So if I reload, I can hammer this button and nothing happens, and all the click events are only processed once the loop basically is done. Now here we see the single threading in action. We have this event listener, we handed this off to the browser, and therefore this event listener is not blocking JavaScript. But this loop here, this actually is not handed off to the browser, and there is no way of handing this off. This loop executes, and JavaScript execution is blocked until this operation is done, because you can only execute one operation at a time. Now that actually proves the point I showed you on the slide early already. Also interesting, however, is that this handed off task also is only able to execute, so to say, or to execute this function once the loop is done. However, it makes sense if you think about it. I mentioned there is only one thing you can execute in JavaScript at a given time, and whilst the loop is running, that is that loop. If we click whilst the loop is running, the browser recognizes that click, sure, and it knows it should call this function, so it does that. But this function is a JavaScript function, and in JavaScript, we're occupied with this for loop. So this function is kind of memorized by JavaScript that it needs to execute that, but it only does that once this operation finished. And that's really important to understand. That's how JavaScript works and how it works with async code and with synchronous code. And what it actually does is it uses a concept called the event loop. You might remember this slide. I showed it earlier in the behind the scenes module. We had the heap, the stack, and I mentioned the event loop there already, but I mentioned that it would become important later. Now is later. Now let's have a closer look at that event loop here. So what is the event loop? In the end, the event loop helps us deal with async code, you could say. It helps us deal with callback functions, which typically are used in such async code scenarios. Let's imagine this setup here. We have this code and we have our stack. Now in this code here on the left, you see we're defining two functions. Then here I set a timer. Once this timer is done, we call the show alert function, which is the second function we define here. And after the timer, we also call greet here. Now when this code executes, the stack, which is part of the JavaScript engine as you learned, will do certain things. Now also be aware that certain other things will be offloaded to the browser, that the browser kind of gives us a bridge where we can talk to certain browser APIs from inside our JavaScript code to, for example, offload certain work. So let's say this code executes now. Now what happens is the two functions are created. That's the first thing which happens, the greet and the show alert function. And then the first function that is called is actually the built-in set timeout function. Now, set timeout does one important thing. It reaches out to the browser because it actually is a browser API made available in JavaScript and sets up the ongoing timer there in the browser, so to say. So the browser manages this timer, as I mentioned earlier. And then in JavaScript, this function is done. And as you learned, it is really done. It does not block any other code execution. So the timer is still there, but that is managed by the browser. JavaScript is done for now. So the next thing, which actually happens, is not that show alert executes. Keep in mind that this takes 2 seconds. The timer takes 2 seconds. Instead, JavaScript doesn't wait for this, as I explained, and it instead moves on to the next line. It moves on to the greet method. So now greet executes before the timer is completed, right away after set timeout is done and the timer is offloaded to the browser. Then greet executes. In the greet function, if you have a look at the left here, we call console log. So that's of course also executed. And with that, we're basically done with the code on the left. Now, at some point, the timer is completed though, and let's say that actually happens whilst our greet console log code executes. Of course, this code executes very fast, it does not take it long, it's not such a long if loop as we wrote it, but still, it takes a couple of milliseconds, even if it's just a few. And now let's say whilst we're executing console log, the timer finishes. Now we need some way of telling our JavaScript code, the JavaScript engine, so to say, that the show alert function, which was registered as a callback for the timer, should be executed. And for this, a message queue is used. This is provided by the browser, and it's also linked to JavaScript, so to say. Now, in this message queue, the browser registers any code that should execute once we have time for it. In this case, the timer. So here, the show alert function, this callback, so to say, is registered as a to-do task once the JavaScript engine has time for it. So now the timer is done and this task is registered. Please note, show alert does not execute at this point. It's just registered as a to-do. The only thing which is really executed in JavaScript at this point is greet and console log, because that's what we're currently doing there. So now with that, let's say in JavaScript, we're done with that. Console log executed, and therefore greet also is done, and the call stack is empty again. Now we need to get that message or this show alert to do in our call stack. We know it's a function in JavaScript. It should now be executed. And for this, we use the event loop. The event loop, just like the message queue, is built into the browser. And most JavaScript environments, for example, also Node.js, have that concept of having such an event loop. It's just important to understand that it's not part of the JavaScript engine, it's really part of the host environment of JavaScript, so of the thing which uses that JavaScript engine. So the event loop is part of the browser, and the job of the event loop in the end is to synchronize the call stack in the engine with our waiting messages. So in the end, what the event loop does is it runs basically all the time, and it always sees, is the stack empty and do we have pending to-dos? And if the stack is empty, then the event loop executes, so to say, and it pushes any waiting messages or any to-do functions, therefore, into the call stack. So the event loop waits until the call stack is empty, and once that is the case, it moves our message or the callback function we registered earlier as a function that is now actively executed into our call stack. So the message queue is now empty, and now this function runs in our JavaScript code. So here show alert runs, this calls the built-in alert function here, as you can see on the left. Once this is done, the call stack is empty again. This is what the browser does behind the scene with the event loop and with our code, and also with these callback functions we hand off to the browser APIs. And that is a pattern that typically is used for async operations. So if we have a look at this code again, what we do here with add event listener is here we're handing something off to the browser. We're handling this click listener off to the browser, and we tell it that this is the function that should be executed once a click occurs. Then we continue in JavaScript, and we have this long taking task, which basically occupies our call stack. It's not part of a function here, but it therefore is basically running in an anonymous function, you could say, in a big anonymous function that wraps everything, if you will. So this now executes there, and the call stack in our JavaScript engine therefore is not empty. So if we click the button, if we reload whilst we're still doing this for loop, then this click is registered and the browser pushes this function as a to-do onto our message queue, but the event loop sees that we still have work to do on the call stack, and therefore it waits to execute this function until the call stack is empty. And that only happens once this executed and once we logged this result to the console, which is why we see the clicked output only after we see the result, even if we click the button whilst this was still going on, simply because of how the browser handles this. And this is really important knowledge. You need to know what JavaScript does behind the scenes here to understand why you write code in a certain way, and to understand that, for example, this code here executes before this code, even though you registered this first, because this is an async task and you wait for this to happen, but you don't wait for it by blocking your JavaScript execution, but instead that continues, and only some things like this for loop, which you typically don't write like this, you don't have such long running for loops typically, such operations can block your JavaScript code. These expected long taking operations, or these operations like event listeners, where you don't know if and how often they will happen, these are handed off to the browser so that your JavaScript code is never blocked. Let's now dive a bit deeper into callbacks and async code, and for this I'll comment out this for loop, don't really need that here, and instead let's say here where we have track user handler, instead of just logging clicked here, we want to get the user location. Now we can get this with the navigator object and then geolocation. This is a built-in API which allows us to reach out to the browser to get the user location with the help of getCurrentPosition. Now getCurrentPosition is a method here which actually, if you have a look at its parameters, takes 3 potential parameters. A success callback, basically a function that is executed if the position was successfully fetched. An error callback, which is executed if the position was not successfully fetched. And then an options object where you can configure how that should be fetched. And you can either set up some named functions and pass in the names here, like I'm doing it here for the event listener, or you use anonymous functions. So here, for example, I'm using an anonymous arrow function where I get my position data, and then I can console log the pos data. That's my success callback. As a second argument to get current position, I have my error, and here I can console log that. This will be the error callback. Well, and then if we wanted to, we could pass in a third argument, an object, where we can configure that. For example, set a timeout, how long we want to wait for this to resolve until we throw an error, and so on, but I'll not do that and go with the defaults instead. Now, if we do that, what happens is, if I reload and I click track me, here I'm asked if I want to allow access. I click allow here in this case, and now this will take some time to locate me and get that location. And after a while here it's done, and we can expand this to now also see the coordinates if we want to, and yeah, read them and do whatever we want to do with that in our app here. Quite convenient for many apps. Let's say you're building a food delivery web service, then getting the user location might be useful. Now here we got these cases. Now to also simulate the error case here, let me reload, click this again, and now I block this. And now you see I get this error object, and it's thrown or printed by app.js line 10. And this is simply the line here in this error callback. So this is how these callbacks work. And just as with add event listener, getCurrentPosition offloads this task to the browser. And when it's done, it pushes this into the event loop to execute our code there. Now, just as before, if we do something after calling getCurrentPosition, like outputting this to the log here, then this line will run before we print either of these lines, simply because we execute this code, push it to the browser, and no matter how fast it finishes, JavaScript moves on to the next line, and the browser is then able to push this into the message queue so that the event loop moves it to the call stack, but the event loop will only do this once the call stack is empty. So since this line is executed right away, even if we would get the position instantly, still, this would print first, because that goes into the event loop first. This code here, inside of the callback functions, can never be executed before this code, because this is offloaded to the browser, and the browser always has to take the way over this message queue and with the event loop to then go back into our current JavaScript execution. Something which is not the case for this line. This is executed immediately after handing this off to the browser. So this line will always execute before one of these lines, no matter how fast they actually are done. Even if it would be done instantly, we would still execute this here first. This is how that works. So if I reload here, click track me, click block, still getting position was printed instantly because JavaScript is non-blocking. Now let's take this to the next level, and let's say once we have a response, I actually, for whatever reason, want to set a timer of 2 seconds, and only after these 2 seconds, I'll print the response. So here I'll have another anonymous function, another callback in there, and in there I console log pause data. I have access to pause data because of that closure thing, as you learned. This is a function nested inside of this function, so this will work fine, but I only do it after 2 seconds for, as I said, whatever reason. So now we have basically a callback, this one here, in another callback, which in the end is part of another callback, so track user handler, which also is a callback of the event listener. And we can already see that this gets a bit hard to read over time. The more callbacks you nest, the harder your code can get to read and maintain. And we'll have a look at this in a second. For now, let's just see if it works. If I save that, and I reload and click track me, and I click allow, it takes a while to get the position, and then it takes an additional 2 seconds because of the timer, and only after this will show this object. Now, the idea here really just is to show you that you can nest these operations. You can have an async operation in an async operation, but of course this timer is only kicked off once the location is there, so once this outer callback function executed. It's also important to understand, by the way, now that we speak about timers, that if you set a timer here, so in track user handler, but not inside of get current position, but right before outputting this console log, if you execute this function right away, so if you set a timeout of 0 here, you will still see something interesting. If I console log timer done here, would you expect that this runs before getting position or thereafter? Well, let's find out. If I reload, I click track me, you see, actually getting position ran first and then we saw timer done, even though I set a timer of 0. And the reason for that is related to what I explained a second ago. We hand something off to the browser, no matter if it's an event listener, the position fetching, or this timer, and then for the browser to execute the callback function, it always has to take the route over the message queue and the event loop. And therefore, this code always executes first. This executes right away after set timeout executes, and even though the timer immediately finishes, this function still only executes after this line is done. And this, by the way, has one important implication. This is the minimum time after which the callback function will be executed. It's not the guaranteed time. If it were guaranteed, it would need to run immediately. If we had the long-running for loop here, then this timer would only execute once the long-running for loop is done, which might take 3 seconds. So this is not a guaranteed time. No matter if it's 0 or 3000 or whatever it is, it's not guaranteed, it's the minimum. And the same for a set interval. It's the minimum where JavaScript and the browser try to run this, but they're only able to run this function if the call stack is empty. And if something is blocking the call stack, that will go first. So here this line will always run first because this always has to take the route over the message queue and the event loop. So we learned a lot about async code, and that is crucial knowledge you need as a JavaScript developer. No way around that. You need to understand this. Now with this out of the way, let's have a look at readability. This code here can be cumbersome to read, right? If we have such code where we have callbacks nested into each other, like for example here, where we have some callback with a set timeout with another callback, and then maybe another function that uses yet another callback, then we enter something which has a nickname of callback hell. Because it gets cumbersome to read and maintain, it can be hard to track what's nested in where, which variables can I access where. This is really not nice code to look at. Now, thankfully, JavaScript has a solution for that, and that is the concept of promises. Promises allow us to write cleaner code because they look like this. We have some task, then we use the special then keyword. We then pass a callback to then, but then if we have another task that depends on the first task, we simply add another then block instead of nesting it into each other. And therefore, we have only one level of nesting here instead of having multiple levels. And that makes our code way more readable. Let's have a look at that in practice. Unfortunately, set timeout and get current position have no promise version, so we can't add then after that and try to use that promise approach there. More modern web APIs offered by the browser typically embrace promises and often only support promise syntax, but these older functionalities like set timeout, which have been around for forever almost, well, these still use callbacks. Now we can actually wrap them into promise supported code if we wanted to, and that's what we'll do here to also understand how a promise works internally. And later in this course, we'll also see functionalities built into the browser that natively embrace promises. So let's start by adding a new function here, and I'll just name it setTimer to not clash with setTimeout. And this can be an arrow function or created with the function keyword, up to you. And here in setTimer, I want to get the duration as an argument. I'll need that. And now in here, I'll call setTimeout and pass the duration as the second argument. The question is, what do we in the first argument? What do we do here? Well, we have to call a function here. As I said, there is no way around that, but now I have the callback function here in this separate function, and I'll later be able to reuse that in the places down there to kind of make that easier to work with. So now we have setTimeout here, and now what we have to do, or what we can do here, is we can build a new promise. A promise is in the end an object with the functionality or with the idea of having such a then method which you can call on it. So here we can create a promise, and you can store it in a constant with any name by calling new promise, just like that. Promise is the constructor function or the class built into JavaScript, and therefore we can construct it like this. Now the promise here itself takes a function as an argument. It takes a function, the constructor takes a function, and this is actually a function the promise API, so to say, will execute right away when this promise is constructed. So when we build the promise here, this function which we pass to the promise constructor is executed right away. It's called from inside the constructor, you could say. And it's a way for us to configure what this promise should actually do, what it should wrap itself around. This function takes two arguments. So this function we pass to the constructor, this function here, takes two arguments. And each argument itself actually is a function. It's a resolve function, therefore typically called resolve, and a reject function, typically called reject, but you can name these parameters however you want. It's up to you, it's your code here. Now in the function body, as I mentioned, this executes right away when the promise is created. In the function body here, you can define what should happen. And here I actually want to set the timer. I can access the duration because of the scoping thing you learned with functions. And now the timer is set when this promise is created. Now in here, we have our async code, then this callback in the timer will only execute once the timer is done. And after creating this promise, so not after the timer is done, only after creating the promise where the timer is then kicked off, I will return the promise here so that I can use it wherever I call setTimer. It's returned as a return value of this function. Now here, inside of setTimeout, I will call resolve. So I'll use this first argument, which I set as a function, by simply executing it. Now we'll not pass the concrete function here into promise. Instead, that is built into the browser. The browser executes this function for us when it creates a promise, and it passes the resolve and the reject functions into this function here for us. So the resolve function is coming from the browser, from the JavaScript engine to be precise. That is passing in that resolve function. And it's a function which internally will mark this promise object, which is created here in the end, as resolved. So as done, you could say. And I call resolve here once the timer is done. You can also pass a value here to resolve if you wanted to. For example, some text, but that can be anything. Can be an object, can be an array, a number, whatever you want. Here it's some text. So I pass this to resolve. For the moment, I'll ignore reject. Now we have setTimer. Now down here, we can use setTimer. I can call setTimer, not setTimeout, but setTimer, so my own function here. I call this in here, and now we don't pass a function to setTimer because setTimer doesn't want a function. It just wants a duration. So here we could still pass in the 2000 milliseconds, and those will be added to the wrapped setTimeout. Now setTimer does return a promise in the end, as my tooltip also shows here. It returns a promise because that's what I do inside of setTimer. I create a promise and I return it. Now on this promise object, you can call then. You can call this then method. And it will basically execute whenever this promise resolves. Now, a promise can also resolve more than once, more on that in a second. For now, it resolves once resolve is called here. And that happens when the timer is done, in this case here. That's the logic we wrote in this promise configuring function, which we passed to the promise constructor. Now in here, we also get any data that might be resolved. In this case, that will be the text. And then here I can console log the data here and maybe also the position data here if I wanted to. Now what you'll see is that if we save that and we reload, if I click track me and I allow this, you will see it again will take until we have the position and until the 2 seconds are over. But thereafter we see our location, but we also see done. And that of course is the text coming from inside my promise. What we did here is sometimes also called promisifying a built-in API. I'm wrapping the set timeout API with my promise logic so that I, yes, have some extra effort up there. It's a bit more complex code, but then I can always use the timer here instead of that callback way here with just my promise way. I can always call then here now and then have my callback function registered here. Timer done. And whilst the benefit might not be super obvious when we just do that for the timer, imagine we have something similar for get current position and so on, and we then just have a couple of then calls chained after each other, as it's called. And that's actually what we'll have a look at next. So to dive a bit deeper into promises, let's actually also promisify get current position. So for this, I'll add another new function, get position could be a name. And we could pass in an argument. We could accept the argument, maybe options, opts, whatever you want to call it. And in there, we call navigator get geolocation get current position. So we make that call inside of get position. Now to get current position, we need to pass in these callbacks. There is no way around that. There is no promise version of get current position. So here I have my success callback. You can name this piece of data you're getting however you want. And I have my error callback, and I'll forward the options I might be getting here. So now we have the callbacks in here. And now the idea is that we again wrap this with a promise. So here we can again create a promise, and again you could name this differently of course, by calling new promise. As you learned, the promise then takes a function as an argument, and this function in turn takes two functions, a resolve and a reject function parameter. And now in here, in this promise, I want to make that call, and then I want to return promise here. And now we can again resolve here and maybe resolve the success object so that we pass the data we're getting from get current position into our promise, so to say, and wherever we listen to it with, then we get that data. We'll take care about the error later. Now we have a promisified version of get current position. And therefore down here, we can call get position like this, and now not pass in these two callback functions. So we can cut that and instead call then here. And here we get the success data, which is my position data in the end. And I can console log position data. So now we promisified that, and therefore if we reload now, and I click track me again, and I click allow, you will see this gets my position, and after a while, this gets printed here. So it works like before, but now wrapped in a promise. And now we can see the power of that when we combine this with set timer. Previously, I set my timer in here, and we can still do that. I can set my timer in here, once we're done basically, and then wait for 2 seconds. And then here I can add then, and then I got my data from the set timer method, and I can then console log pause data. But now again, we have some nesting here. So this would be the not so intelligent way of doing that. The better way is to take advantage of a concept called chaining. Here I get my position data, right? I get my position data of that promise. Now I want to set a timer in here, and therefore I can call set timer. And what does set timer do? It creates a new promise and returns it. Now actually here, we can return this inside of this function I passed to then, and what happens there is that the overall promise, which is created here basically, is now set back from being resolved to being pending. A promise can be pending or be resolved or have an error. So it was resolved after we got the position. Now by returning something inside of that function here, we set it back to being pending, and it will now wait for this promise here, which we returned here, to resolve. And I can now add a new then block after this first one. And you typically write it like this across multiple lines. This is all belonging together here, but it's simply more readable. And here I then get the data of that inner promise, which in this case is the timer data I could log. If I also needed the position data here, we could store this in some variable outside of this chain here. Position data, so that we can store our pause data in position data here, and then also access position data, which is defined outside of all these functions in this last function here. So this is how we could pass this on as well. And now we have something which is called promise chaining. We have multiple steps in this promise where we wait for the first promise to finish, and then we return something new here, which doesn't even have to be a promise, by the way. If it would be other data like a string, it would be wrapped into a promise automatically. Then we'll wait for this promise to resolve. For non-promise data, that would of course be the case instantly. If you pass back a promise instead, we wait for that to finish, which in this case is happening once the timer is expired. Let's set it to 2 seconds here maybe. And then once this promise finished, we move on to the next then step and execute that with the data of that returned promise. Or if you just return data like this, I said it's wrapped into a promise, but of course it resolves instantly, and then data would be the data you returned here. So in this case, that string. Here, however, I'm passing back the result of that function, which is a promise. We wait for this promise to finish, to resolve, and then we make it into the next then block. So this is promise chaining, and this is a powerful concept which lets you escape from callback hell, because now we have step after step instead of step inside step, which would lead to a lot of nesting if you have a lot of related operations. So now with that, if we reload and I allow access here, you'll see we'll have to wait a bit, and after we got the position and after the timer expired, we will get this output we got before, now with the help of promises and promise chaining. So we saw promise chaining in action, and really important to emphasize here, you don't have to return a promise in here. You can return any kind of data and it will be converted to a promise and wrapped into a promise. The core idea of promise chaining is that you can have step after step, and this step here, for example, the second one, will only execute once this step is done. So once this promise is done, we make it into this step, and then once whatever we returned here, which is wrapped into a promise, if it is not a promise already, once this is done, we make it into this step. A very powerful concept. Now let's have a look at errors, because of course things can also go wrong. For example, when we're getting the position, we have this error callback in our promisified version here. Now what if we have that error case? Because, for example, permission is not granted. Well, then previously we would handle our error here. But now, since I moved this into a promise, I want to pass this on to my promise chain so that we can somehow handle it here. Now that is done with this second argument, this configuration function for the promise constructor gets, the reject argument. We can call reject here instead of the error callback and, for example, pass our error object into reject. Now what reject will do is it will mark the promise as failed. I mentioned that a promise can be pending or resolved. It's pending whilst we're waiting for it to be resolved, basically. Once we resolved it, we can set it back to pending by returning something in the then block. Now there is another state, and that is the failed state, basically, that we have an error. So the promise is now not resolved, it's not pending, but it has an error. Now errors are not handled with the normal then functions here, with these functions you pass to then, I should say. Instead, then takes a second argument. The first argument here is the callback function that should be executed if the promise resolves. The second argument is the potential error function we might have. So here we could expect our error object, you can name it however you want here, and for example, log that here, or send it to your own server where you want to write it to some logs, or do whatever you want. So that's a second argument I'm passing to the then method here. It's a second function I'm passing to then. The first function is the success case when the promise resolves. The second argument here is the failure case, when a promise does not resolve, but instead rejects. So now if we go back and reload and I click block here, we see that error here, for example. User denied geolocation. We also got this output. I'll come back to it in a second, but for now we see that the error is being output here. So this code executes here. Now, you might argue that we're losing some of the benefits we gained with promises if we have a second argument here, a second function. Whilst it's not nested into another callback, we have more callbacks next to each other. And whilst this is perfectly fine to use, you have an alternative to that. You have another method you can add to your promise chain, for example here, and that's the catch method. Now, the catch method can be added on a promise, and you can add it anywhere in this chain, right after executing this function, which returns a promise, or anywhere thereafter, though the exact position does matter. Let's, for example, add it here after the first then block. Add catch here, and we have a then block thereafter, which belongs to the same chain still. And here you can now have your error function. Now let's try if it works before we dive into what it does. If I click track me and I block, we get that error output. So it works. But what does it do? Catch actually does exactly the same as if you pass it as a second argument here to one of your then blocks. So it's really just an alternative to that. But both approaches, no matter if you use the second argument or a catch block, work such that they catch any errors, any rejections produced anywhere in your promise chain prior to this catch block or prior to the place where you added it as a second argument. So if we had more then blocks here, which we don't have in this promise because it doesn't make sense there, it won't work there. But if we had a longer promise chain with multiple then blocks, then no matter if you have an error here or in the promise returned here or here or here, if any of these promises rejects, this logic will run, or the logic in the nearest second argument. So if this promise rejects, for example, it's not just the case that this then block will be skipped. Instead, all then blocks thereafter will be skipped until we reach a catch block or a second argument to handle the error. So in this scenario here, which will work, this then block is skipped if this promise, which is returned by get position, if this rejects. So this then block is skipped, and instead we make it into this catch block. But this then block will then execute again. So the catch block, this catch method, does not cancel the entire promise chain. Instead, it just does its thing, and you can even return something new here, which can be a promise or some other data that will be wrapped into a promise, just as it's the case in the then method. And now any then blocks thereafter will continue to work. So the positioning of the catch block does matter. If you want to kind of cancel the promise chain, you have to move it to the end of all your then blocks, because only then you make sure that if one of them rejects, the other ones are skipped and you make it into catch. If you add catch somewhere in the middle, then all prior ones are skipped if one of them rejects, but then blocks after catch will be executed. So here in catch, what happens is we cancel or we skip all previous then blocks if one of them rejects, but then here we return new data, for example. Even if you don't return anything, you return undefined basically, and that sets the promise back to pending, and if you have more then blocks thereafter, those will execute once the pending promise resolves again. So it does not cancel the promise, it allows it to continue. So here, for example, if I return on we go, and you'll see I click block, we print on we go here. We still get undefined because position data is undefined because we skipped this then block, as I explained, but data here is what I return here in the catch block. And that's not a bug, that's of course very useful because it allows you to structure your chain such that certain parts of it can be skipped if necessary, but it doesn't necessarily crash entirely just because one part failed. If you wanted to crash entirely, you can always force that by moving catch to the end, of course. If you have catch somewhere in the middle, then the promise chain continues after catch, and of course, you could have another catch in there to handle an error in here. Because if this rejects for some reason, this catch block, which came before it, will not do anything. You would need a new catch block or a new second argument to handle any errors here or in other then blocks thereafter. So this is error handling and how promise chaining works with errors. Really important to understand that. Gives you a lot of power and all the flexibility you need to write great applications which also can deal with errors in a graceful way. So promises are a really important concept in JavaScript, and you'll see them a lot, especially in modern JavaScript, which we are of course learning in this course. They're everywhere, as you will also see once we dive into HTTP requests, and as you will also see in many projects you work on. As soon as you start working with async code, promises will be used a lot. Now, promises are great, and I like the syntax a lot. With then and catch, I think that's very clear to read. It makes it clear that these steps execute after each other. It at the same time makes clear that getPosition executes next to next with this line and this line basically, so that we don't wait for these steps to finish just to then execute these steps. So really great to have promises. It's really a great syntax that makes working with async code so much easier. Now let's temporarily comment out these two lines. I don't need them right now. And therefore all we do in track user handler is we get the user position, we catch a potential error here, and then we have this then block here where we either wait for the timer here, where if we successfully get the position, we skip the catch block, and therefore then here executes on the result of the timer, or we got the on we go text here. Of course, you might want a different error handling here and then, and basically react depending on whether you got the timer which expired or you got an error before. And that, of course, depends on what data you return in the steps before. But for now, let's say that's the approach we have, and hence if I reload here and we click track me and we click allow, you'll see we'll wait, and at some point of time, we'll have the position, and we have the timer in there expired, and then we get the output we expect. So that's what we saw early already. Now, nothing wrong with doing it like this. Modern JavaScript also has an alternative syntax to that, and that's really important to memorize, which is why I'm saying it right away, which still utilizes promises, but which actually allows you to omit the then and catch method here, and therefore make your code look a bit more like synchronous code, so the normal code you write everywhere without promises, than it actually is. And that's async await. Now, what is async await about? You can use async await in functions and only in functions. That's important. You enable it, so to say, by adding the async keyword in front of your function keyword. For functions created like this, you would async here in front of your function name, so on the right side of the equal sign. So that's how you do it on expressions. On declarations, you add it here in the front of function. And then, with async added here, the function internally changes, so to say, or what happens in there invisibly changes. With async in front of it, this function automatically returns a promise. You see here in my tooltip, it tells me that this returns a promise. Please note, I never call return in this function, only in the nested functions, but not in this function itself. I don't return a promise here. If I remove async, we actually therefore correctly see void here, which basically means it returns nothing. But as soon as I add async, this changes, and now my IDE tells me that this returns a promise. My IDE is correct. By adding async here, which is a keyword supported by JavaScript, this entire function wraps all its content into one big promise. So it basically does this wrapping up here with new promise and so on behind the scenes for us, and wraps all that code in that initialization function you pass to the promise constructor. It does that behind the scenes. So that's all in a promise. Okay. One effect of that, of course, is that you could now call then in the place where track user handler is executed. Now, here the browser executes that for us, and the browser, of course, will not automatically add some then block here. And here I also don't really want to execute anything on it. And you don't have to. It's just one thing you could do. The more interesting thing now is that inside of this invisible promise, you have access to another keyword. Because we added async here, we can use the await keyword. We add that in front of any promise So for example, here getPosition returns a promise. So in front of that, we can use await. Now, what does await then do if we add it in front of a promise? Well, it kind of waits for the promise to resolve or to fail, and the next line thereafter will only execute once that is the case. The data which might be resolved, the position data, for example, here, will then be returned, so that here we can say pos data equal await getPosition. Now I can basically omit that code line here, don't return setTimer, but instead call setTimer, which I previously did inside of this first then block, so after getPosition resolved, in the next line. So now I wait for this getPosition promise to resolve, and only thereafter this line executes. The result of getPosition, of this resolving of this promise, is stored in this constant. Thereafter we set the timer. Now the timer returns some data, so here we can have the timer data stored in a constant as well if we need it. I have to add a wait here now, and we're good. Of course, you don't have to store the data. If you're not interested, you can omit this. But here, I want to store it. So now we await this, and once this is done, we move on to the next line, and we await this. Now we have to comment out this code. It will not work anymore. Instead, now we refactored it to look like that. Now I can console log my timer data, which I have here, and my pos data like this, and I can get rid of that variable because of the way this code was rewritten. So at the moment we lost the error handling, but other than that, this is of course a more concise way of writing this of the two then blocks we had down there. If we saved it, let's see if it works. If we reload, click track me and click allow, we now have to wait to get the user position and then wait for the 2-second timer to expire, but then we should see same output as before. So except for the error handling, which we temporarily lost, this seems way better. But what does it actually do? Doesn't it break all the things I taught you about JavaScript, that JavaScript is non-blocking and so on? Because here we clearly are blocking the execution, right? Well, it looks like we are, and that can be the dangerous thing about async await. It looks like we're changing the way JavaScript works, that suddenly we wait for async code to finish and that we block script execution until that is the case. But that's actually, thankfully, not what's happening. Instead, as I mentioned, async wraps everything inside of track user handler into one big promise. And then it actually goes ahead, and whenever we await for some other promise, which is wrapped in that big promise to resolve, it in the end just returns this as part of that big promise it created for us and adds an invisible then block. In the then block, it will then get the result of this promise and store it in this variable, which is available in that big overall promise, so to say. So in the end, it replicates this then block behind the scenes, you could say. And the same, of course, for this promise. So it doesn't really block code execution. You could say this code simply gets transformed behind the scenes. It gets transformed to a version which still uses then blocks. It's the normal promise API, the normal promise object with the normal then method, just transformed behind the scenes so that we as a developer can write shorter code, and the overhead of adding the then blocks and so on is done by JavaScript behind the scenes, you could say. And that's really important to take away. Async await does not change the way JavaScript works or executes. It just transforms this code behind the scenes. And therefore, we just have a look that's different, and it looks like we're actually waiting here. And we are, of course, in this function, but only in this function because we have a couple of then methods chained after each other here in the end. That's what's happening here. And therefore, we can reap the benefits of having more readable code without any downsides. You just have to be aware of the fact that there is no magic going on and JavaScript is not suddenly changing, but instead that we're just having the then stuff going on behind the scenes. And it can be a common error source or something which, if you're new to JavaScript, can be hard to understand, where you think that now you're changing the way JavaScript works. You are not. You're having an invisible transformation here. So async await can be great to write shorter, more concise code. But of course here, we lost error handling. We have no replacement for the catch block at the moment. How do we do that with async await? Well, await always moves on to the next line as long as the previous line resolved. Now what if we have an error? Well, since this looks like normal synchronous code, where we execute line after line, and in the end we are doing that because of the invisible transformation, we can use the normal synchronous error handling we learned about way earlier in the course already. We can use try catch. So here we can try something, for example this line, and then catch any error we might be getting. And then handle that in the catch block, for example by printing it or by doing with it whatever you want to do. And now everything inside of try, so all the steps you might have in here, for example 2 steps, will only execute if the first step succeeded. So if this step succeeded, we'll also execute this step. Otherwise, if this step failed, or if this promise rejected, this step will not execute, and then we'll just make it into the catch block here. Whoops, and of course I wrote this incorrectly. This is the correct syntax. So we make it into this catch block if one of these 2 promises rejects. If the first promise rejects, this line here will not be executed. If the first promise does not reject but resolves, then this line is executed. But then if this line would reject, which in this example is not possible because setTimer never rejects, but if it would reject, then we would make it into the catch block. This line thereafter will always run. This will always run after try catch. So this always executes no matter if you made it into try or into catch before this line. And therefore here, of course, we might want to work with 2 variables here instead of constants, which we only have available inside of the try block because of block scoping. Now I have 2 variables available in the entire function. We assign new values in the try block, and then we log it thereafter. So this is how you can handle errors correctly in async await world. Instead of catch, with try catch. And you can, of course, put whatever you want into try. You just should be aware of the fact that if one of the things failed, the other steps are skipped, just as it was the case with catch in the end. And on the other hand, if both succeed, we of course don't make it into catch, but we always execute the line thereafter. Hence, now if I reload, and we first of all see if it works in a success case by clicking allow in the prompt, we'll see that after a short while, we'll get the output we're used to. If I, on the other hand, reload and I click block, we get the error being printed here, and thereafter we see undefined, because these 2 variables never received values. So this is how you can handle errors with async await. So async await is a nice alternative to the then and catch blocks, and ultimately it's up to you what you prefer. In a lot of my tutorials, I actually like to use then and catch instead of async await, because I really see a danger here with async and await, that you could think that these steps really run after each other because JavaScript always executes all code after each other, when this actually is not the case. Async code and all these async operations are always provided by the browser, such that they can be offloaded to the browser as you learned it earlier in the module, and the browser comes back to you once it's done. That has not changed, and async await does not change this. It just does some invisible transformation behind the scenes. If you understand that, well, this obviously is a bit shorter than this down there, so you might prefer that. Ultimately, it's up to you. In modern browsers, this might be a bit better from a performance perspective. Async await might be a bit better, simply because browsers can also parse and execute this in a more optimized way, but it'll not be a huge difference, might not always be a difference for all possible examples or use cases, and therefore ultimately I'd go with whatever you prefer. The most important thing here just is that you understand what's happening behind the scenes. One real downside you can have with async await, though, is that you can't run tasks simultaneously inside of the same function. Previously with then and catch, these lines down there, right, if I comment them back in, you might remember they executed right away. We called getPosition here. In the end, what we did is we called getPosition, and then we had all that code here. And the thing was, this executed, and then we had these steps, which would eventually execute. But of course, the steps after getPosition, because of the way JavaScript works, would execute right away. So this timer would be set right away, and this console log would execute right away. So if I temporarily comment out this async await part up there and I remove the async keyword just to bring back in memory what happened there, also comment this out, and I reload, you see if I click track me, getting position executed right away, timer was set right away, and thereafter our promise thing did its job. Now with the new syntax, if I comment this back in and I add the async keyword again, and I remove this code, but I leave the set timer and console log down there, that will of course also execute after these steps, but the problem is really only after all these steps. So now if I reload and I click block, for example, you see getting position and timer done executes thereafter. Now why is that happening? Because of await. This does not pause code execution, but behind the scenes, all these steps in the end get wrapped into their own then blocks. And therefore this has its own then block as well. And therefore this only executes after this is finished. It is as if down there we would have added an extra then block where we had this code inside of it. This was not the case. So async await is not that great if you have a function in which you need to execute or kick off multiple things simultaneously and don't want to execute everything after each other. Then this is not ideal because right now we really got a different behavior than before. Of course, you can fix this by offloading this into a different function, which you kick off simultaneously with this function, and so on. So there are ways around that. It's just important to be aware of the fact that everything in this function executes after each other if you start using async await. Another downside or thing to be aware of is that async await is only available on functions. So if you had some code outside of a function, let's say here you had some promise-based code, you call set timer here, which of course returns a promise as you learned because we promisified this, then you can't use await here because await can only be used in functions which are marked with async. And this is not part of a function. It's part of this global anonymous function which you get automatically, but that's not an async function, so to say. So here you would have to wrap this into, for example, an IFI in order to be able to use that. So here we could use async like this, and then wrap this into an IFI, and that would now be a workaround to use await here. Yes, this would work, but of course that's also not that beautiful if we really just want to replace this line here, where we otherwise would have to use then. So async await might not always be preferable if you need to introduce a function just to use it. If you have a function anyways where you use a promise in, then using async await of course is not too difficult. Now, to come to an end, there are a couple of nice methods you have related to promises, which sometimes can be handy. Let's say you have multiple promises which you want to orchestrate in a certain way, which means you want to make sure that they are executed together in a certain way. Now, we are executing two promises here, get position and set timer. In this case, after each other, and for example, if get position fails, set timer will not be executed, it will be skipped. Now, let me go to the end of this file here, and in there, let's say I have the same promises, get position and set timer, 1 second, and I want to make sure that only one of them executes, and that's the one which is faster. Of course, for this dummy example, you could argue if it makes sense to either get the user position or to wait for some timer. But actually, you could say, yes, it makes sense. I want to wait for 1 second. And if I haven't gotten the position by then I want to do something else. Sure, you could achieve the same by setting a timeout in the configuration object of get current position. But if we didn't have that option or we had some other reasons to do it differently, well, then here, what we can do, we have our two promises here. And now we can use promise with a capital P, so the promise constructor function in the end. And instead of constructing it, we can call a method, a static method on this promise constructor function, or on this promise class, if you will. And there we have the raise method. Now, the raise method takes an array of promises, so of get position and and set timer, for example. So two promises, or functions that yield promises, are passed into raise. And then raise itself also returns a promise. A promise with the result of the fastest promise you pass to it. And you can build a normal then catch chain here based on race. It returns a normal promise. The only special thing is that the data it returns will be the result of the fastest promise here. They will both be kicked off at the same time, and the one which first finishes will then be handled by the subsequent then catch promise chain. So here I get back some data, and we can console log that data here. And here, for example, if I save that and I reload, you see I get asked here, and since I didn't even reply, I get done here, which is the result of my timer, because that 1 second timer executed faster than get position. And if I then do click block here, nothing happens with that, because race only cared about the fastest promise. So in this case, this was the winning promise. On the other hand, if I reload and I click block super fast, we see now this promise failed, and we don't see done because now the result of the second promise was discarded and the first one finished instead. Now it's worth noting that the other promise which didn't win is not cancelled, its result is just ignored. But for HTTP requests, it might be important to know that the request is still being sent, its result is just ignored. So race can be useful if you're only interested in one of the two conditions and you then want to use the result of that promise and ignore the other one. Sometimes you also have code that only should execute after a couple of promises have finished. Of course, you can achieve that by chaining multiple then blocks or by using async await. For example, here, this code only executes after these two promises have finished. But an alternative also is that you use promise all. Here, you also pass in an array of promises, and I'll go with the same promises as before. And now here, you'll then get a normal promise as a result, but the data of that promise will be the combined data of your other promises. So here I got my promise data, and if we log that, you'll see that this will actually be the combination of all the data the individual promises resolved. Now if I reload here and I click allow, you see this is the result I get. Now this first done call here was from promise race, so ignore that. This here, coming from line 64, that is from promise all. And as you see, promise data is an array where you have the data returned by each promise in the position of that promise when you passed it to promise all. So here we had get position first and set timer second. Therefore, in the data array we get back here, we have the result of get position as a first argument and the result of set timer as a second argument. So this can be useful if you want to wait for all promises to finish before you then want to use the combined data. And we could have rewritten this code, for example, with promise all. Of course, you can also do some operation which is not depending on the promise data at all, in case you just wanted to wait for a couple of things to finish before you then execute some other code. That's where promise all can shine. Important for promise all, if I reload here and I block this, then I get an error here, and only that. So if one of the promises fails, is rejected, then the other promise is not executed, and we're not waiting for all to resolve or all to reject. Instead, we're waiting for all to resolve. But for rejections, we're not waiting for all to be rejected. Instead, if one of them is rejected, this is cancelled, and we just get the error, which we could handle with a catch block, of course. So it's all resolve or at least one rejected. If you want to wait for all resolved or all rejected, and you might have such scenarios where you just worry about have all succeeded or have all failed, then you also have promise.all settled. Now that's really new. All settled also takes an array of promises, like this here. Whoops, just one array though. And then here you also have a then block, which will also give you an array of the promise data. But if I now comment this out so that we only have this going on, if I comment this out and I reload, if I now click block, you'll see I actually get an array with a different kind of data, with objects where we see the output for the first promise, it was rejected, and the output of the second promise, it was done. If I reload and I click allow, We wait for all of that to happen, to get the position, for the timer to expire, and thereafter I get an object again with the descriptions, but now also with the values. So for them being resolved, I get the concrete values here with the position and with the text of done for the timer. So we get a little bit of a different data, still an array, but an object that describes what the promise did. And the interesting thing here is that now, since you got this detailed description, you got more flexibility. It does not cancel the execution of other promises if one of them is rejected. Instead, it still completes or looks at all of them and then gives you a detailed summary of which promise failed and which promise succeeded so that you can use this knowledge here. And if I block this, we still are able to use the response of the timer, for example. This is not canceled, and that's the difference to all, where if one of them failed, we cancel. Here we don't do that. We always wait for all promises to be finished, and then we get that detailed report, if you want to call it like this. So this was a module about asynchronous code, and you learned all the theory about that, how JavaScript offloads certain tasks and how the event loop and how the message queue then is used to get that back into the stack and execute it there. And that's of course very important theory because that really is a core part of JavaScript and explains how your code executes. And then you learned about callback functions, which you use everywhere, and how you can optimize them a bit more by introducing promises where you can write your own promises. There also are certain APIs which uses promises from the ground up, which we'll also see later in the course, which can help you write more readable and more structured code, either with then and catch blocks or with async await. And there are some differences or some things to be aware of. Most importantly, that this does not magically change JavaScript, but just transforms some code. And you'll also learn about promise raise, all, and all settled, which also can help you orchestrate your code and your promises. And this is something very important. This was a very important module. Definitely make sure you understood it. It's relatively late in the course because it's also advanced, but it's a significant and important part of JavaScript. And even if you skipped other modules, this is a core module which you absolutely have to understand.